welcome to your first of 4 reactions of alkenes. The first reaction of alkenes we're going to go over is a hydrogenation reaction. Before we get into reactions of alkenes, it's important to note that the most common reactions of alkenes that you're going to see are called addition reactions. So when we talked about reactions of alkanes, we classified that reaction as being a substitution. We had to remove something and replace it or substitute it with something else. That's not the type of reaction we're dealing with here. In an addition reaction, your double bond is broken and 2 elements are added to each carbon in the double bond. So let's take a look at this in a generic sense, and we will react this with a random diatomic element. Okay, so in an addition reaction, we are going to break the double bond. Okay, so what happens is we have our H's on here still, but we go from having an alkene to having an alkane. All right, so when we break that double bond, we have a position that opens up for us to add an element to each carbon that was involved in the double bond. So one of these will be added to one carbon and the other element will be added to the other. So what you would wind up with is an alkane that has those 2 new elements incorporated in it, no longer has a double bond. So our first type of alkene reaction, addition reaction, is a hydrogenation. And it is exactly what it sounds like. We are adding a hydrogen to an alkene. We can also add these to alkynes, which we'll see in a moment. And it will convert either an alkene or an alkyne to an alkane. So it's going to break one of the double bonds or 2 of the triple bonds. Eventually, you're going to get down to an alkane. To do this reaction, it will require a catalyst. We'll either use platinum, palladium, or nickel, and you want to make sure when a reaction gives that to you, you put that over the arrow because it's a catalyst. All right, so as we said on the last slide, we are going to break one of our double bonds, and what that does is it allows us a position on each of these carbons for a hydrogen to attach. So we wind up breaking our double bond of our alkene, and we add 2 hydrogens, forming an alkane. So we go from being unsaturated with hydrogens to being saturated. And remember, if you remember back to reactions of alkanes, alkanes are very stable, so this wouldn't undergo any further reactions. All right, let's practice a word equation for a hydrogenation reaction. We're told that propene undergoes a hydrogenation reaction in the presence of nickel. So I'm going to start with propene, and I'm going to make sure that I draw this out completely because in the beginning it is really helpful to be able to see what is going on, and sometimes a condensed structural formula makes it a little less obvious to see what's going on. This is hydrogenation, so I know I'm going to add 2 hydrogens to it. Some people may prefer to write H2. I don't at first. I want to be able to see those hydrogens and what carbons are going to. I want to account for both of them. It makes it just a little bit more clear for me. And this is happening in the presence of nickel. Sometimes you'll be given the catalyst. Sometimes you'll have to know that there's a nickel catalyst or a palladium catalyst. You have to add that in to the equation. All right. So, as we talked about on the last slide, in an addition reaction, we break the double bond, and we will add a hydrogen to 1 carbon involved in the double bond, and we'll add the second hydrogen to the second carbon involved in the double bond. So let's draw this out. I'm going to draw it exactly with the same colors it had initially so that you can see what has changed and what has not. If you are very visually oriented, you may want to buy a package. I'm giving you permission. Buy a package of colors, pens, markers, I don't care, highlighters, and use those colors to show you how the reactions are changing, what the products are. Okay, so I've added 2 hydrogens. I have saturated my unsaturated alkene. I went from having propene, and then it's always good practice to label these and name these. This is propane, 3-carbon alkane. All right, so let's take a look at an example where we're starting with an alkyne. Same idea, we're going to break one of those double or triple bonds and we're going to add the hydrogens, and we're going to keep going until we have an alkane. So here we're starting with an alkene. We will wind up breaking 2 of these bonds and adding 4 hydrogens. Notice that we had to account for those extra hydrogens because we have to balance our reactions, guys. So I'm just going to practice naming this because it's good practice. There's 1, 2, 3, 4. So this is butyne. And no matter which way I count it, that triple bond is in the 2nd position. So this is 2-butyne. After a first round of hydrogenation in the presence of palladium, I am going to break this first double bond, and I'm going to add 1 hydrogen to this carbon. I'm going to add 1 hydrogen to this carbon. So what I wind up with now, 1, 2, 3, 4, is I wind up with 2 butene. So these are the hydrogens that I added. But you still have a catalyst and you still have hydrogens. So we're going to go ahead and break that double bond in the alkene, and we are going to add 1 hydrogen to 1 carbon. We're going to add the other hydrogen to the other carbon involved in the double bond. And what we wind up with is full saturation of hydrogens. So now we have, and there's no number because there's no double bond, but we have butane.